Hi guys, so let's get started with today's video. As always, today also we are going to discuss a very important question with respect to the interviews, and that is kth largest element of an array. Okay, so kth largest element of an array, this is basically a heap question. So I want you to understand why is it a heap question. Suppose any question is given to you, how are you going to judge that you have to use heap in it? So what is heap? What is heap data structure and what does it do? So heap or priority queue basically, like min heap or max heap, is basically a tree based data structure, and it helps you find, like, suppose a set of numbers are given, and suppose if it is a max heap, then on the top of the heap the number will be the maximum of all the numbers. Okay, and it is not like suppose I am giving you 4 3 2 1, so 4 would be on the top, but it is not necessary that 3 2 and 1 would be in descending order, or they are in order only. The top element would be the largest element. Similarly, goes for the min heap, that the smallest number would be on the top of the heap and all the numbers below. It is not necessary that they are also arranged in some particular order. Okay, so now if in any question you have to tell the kth largest element of an array, or you just see k, or you just see any particular variable and you have to find the largest number or the smallest number, immediately heap should strike to you. Okay, so similarly here the question is the kth largest element of an array, and the question would be like, suppose you've been given a set of numbers. Suppose I've given you 4 5s, suppose, and 4, and what is asked, it is asked the second largest element in an array. Okay, so the first largest is this and the second largest is this, so we should return this should be our output. Okay, so a brute force approach can be, we will sort the array in ascending order. Okay, suppose we want the second largest number, or we want the second smallest number, suppose. So if we want the second smallest number, so we can find the second number from the start, and if we want the second largest number, we will just take the second number from the end if we are sorting in ascending order. Okay, this is a very brute force approach, and this is the first approach that will come to your mind after listening to this question. But what will be the time complexity? The time complexity of sorting an array is n of log n. Okay, if you apply quick sort or merge sort, the time complexity would be n of log n, where n is the number of elements in that particular array. Okay, now the next question is, can we optimize it? Yes, definitely we can optimize it with the help of heaps. So, like, why are we using heaps? What is our observation here? Suppose I want to find 5. Okay, so now if I will sort it, I will sort 1 also, then I will write 2, then I will write 3, then 4, 5, 6. So now, like, I am sorting, so like I just want this part of the array. Okay, this part is sorted or not, I don't care. Okay, but why are we sorting it? So this is the extra work that we are doing. We just want the key elements to be sorted. We don't want the rest of the array to be sorted. Okay, so that is the extra work that we are doing, and now we have to think that how can we stop that extra work from being done. So that is where heap comes into picture. So now we will simply take a heap of size k. For example, here it is the largest element. So now if the largest element is asked, I will take minimum heap. Why am I taking minimum heap? I will tell you. Because suppose I have sorted the array and I am seeing from the end. So the last number would be the largest and the second last number would be the smallest. For example, if I am taking k elements, so that number, that is my answer, will be the smallest number in that k elements. For example, I want the third largest number. Okay, so third largest number would be 4. And if I am seeing just these three numbers, okay, I'll write it again. For example, it is 1, 2, 3, 4, 5, and 6. And the question asks to tell me the third largest element. So third largest element is 4. But if you see in this part, in like the k elements from the last, you see that 4 is the smallest number in the k size array. Okay, when I'll explain it, it will become more clear. So, okay, so initially I would be given an input of 3, 2, 1, 5, 6, 4. This is our input, okay? This is our input. If you want me to write, okay, let's write it. 3, 2, 1, 5, 6, and 4. So now firstly what I will do is, without sorting an array or anything, I will just push my elements into the min heap. Like I will make a heap of size k and I will push k elements into the min heap. So for example, k is 2, okay? So k is 2. So I will push two elements inside my heap. So as you are seeing that I will push 3 and 2. So first 2 will come. Then 2 will see that okay, is 2 smaller than or greater than 3? 2 says that okay, I'm smaller than 3. So 3 will go down. So 3 will come here, okay? 3 will come here. Then after that, I will start a loop from k till the last element. Okay. And every time you will see that my size of the heap will be k only. At no point of time will my size of the heap be greater than k. I will explain. So initially I've pushed these two elements in the heap. Then my next element comes. I will check, is 1 greater than 2 or smaller than 2. Okay. I am seeing that 1 is smaller than 2. Okay, so I will do nothing. Then I will move to 5. I will check, is 5 greater than 2 or smaller than 2. So I am seeing that 5 is greater than 2. Okay, so I will push this. So I will just pop this out and I will push 5 into the heap. Okay, so now what I will do is I will just pop out 2 and I will just push 5. So 5, as we have taken min heap, so 5 will go down. So 5 will come down beyond 3. Okay. Okay, so now 5 is here. Now I will go to 6. Now I will see, is 6 greater than 3? I will see that yes, 6 is greater than 3. So what I will do is I will pop 3 also and my 6 will come here. And you're understand why am I putting 6 below 5? Because it is a min heap. So the smallest number will always be on the top. Okay. Now my next element come, that is 4. We will check that is 4 greater than 5. We see that no, 4 is not greater than 5. Okay, so we have iterated through the entire array and these are the elements in our heap. So now whatever is at the top of the heap will be our answer. Now you see what is at the top of the heap? 5. And I explained you why are we doing so. Okay, so now the time complexity is reduced from n log n. We are trying to push, in our worst case we might have to take n elements and at any point of time there are k elements inside the heap. So if there are k elements, the time complexity would be log of k and we are doing it for n elements. Okay, so the overall time complexity would be n log k. Okay, so the time complexity is reduced from n log n to n log of k. Okay, because there will be at max k elements in our min heap at any point of time. Okay, so still if you have not understood, please put down in the comments. I will try to explain it with a few more test cases. Otherwise, just try to take the examples that are there on LeetCode and you will understand it. Okay, let's just go through the code. Okay, so this is the code for kth largest element in an array. As I told you that we will be taking heap. So in C++ we can use priority queue. So simply I have taken priority queue and as I explained that initially I will be pushing k elements inside our queue. So simply I have run a loop from 0 till k. So I will be pushing two elements inside our queue and then what are we doing is that we are pushing conditionally. We have started the loop from k till n minus 1 and we are checking that if my queue's top is less than that number that we are at currently, then what we will do is we will just pop out the element at the top and we will push our new element that we have got on our in our array. Okay, so now similarly here we are doing the same thing as we did here and now at the end what did I told you that at the top we will be having our answer. So we simply returned q.top. Okay, so this was a pretty simple question and if you are trying to understand heaps, this is a very good question to start with. Thank you.